8:17 a.m., March 15, 1943. Aerospace engineer Jiro Horikoshi sat in his office in Tokyo, examining blueprints that were about to make his hands tremble. The classified documents spread across his mahogany desk weren't his own designs. They belonged to America's newest fighter aircraft, the P-38 Lightning. Within hours of studying these acquired blueprints, Horikoshi would submit his resignation letter to the Imperial Japanese Navy. The man who designed the iconic Zero fighter. The aircraft that had dominated Pacific skies for 2 years was about to quit his job because of what America had built in secret. The documents had arrived at dawn, smuggled from a crashed P-38 in the South Pacific. Japanese intelligence officers had worked for 6 months to reconstruct these blueprints from wreckage scattered across jungle floors. What they discovered would shatter the confidence of Japan's most brilliant aeronautical mind. Horikoshi, the engineer who believed Japanese innovation could match any Western design, was staring at technology that seemed decades ahead of anything his team could produce. Before this moment, Horikoshi had built his reputation on the Mitsubishi A6M0, a fighter that terrorized Allied forces from Pearl Harbor to the Coral Sea. The Zero could outmaneuver any Allied fighter in 1941. Its range was unprecedented, its agility unmatched. Japanese pilots spoke of their Zeros with awe-inspired respect. American pilots feared them, with good reason. When a Zero appeared in your rear-view mirror, survival meant running, not fighting. The aircraft had given Japan air superiority across the Pacific theater. From the Philippines to New Guinea, Horikoshi remembered the pride in his chest when the Emperor personally commended his design team. The Zero represented Japanese engineering at its finest, combining traditional craftsmanship with state-of-the-art aerodynamics. Every rivet was placed with precision. Every curve served aerodynamic efficiency. The aircraft weighed just 4,136 pounds empty, lighter than most American fighters by nearly 2,000 pounds. This weight advantage gave it incredible maneuverability and range capabilities that shocked Western observers. But American engineers in Burbank, California, had been working in secret. Lockheed's Skunk Works division, led by Kelly Johnson, was developing something that would redefine air combat forever. The P-38 Lightning wasn't just another fighter aircraft. It was a technological leap that combined twin engines, advanced turbo superchargers, and innovations that Japanese engineers hadn't even conceived. When intelligence reports first described the Lightning's capabilities, Horikoshi had dismissed them as enemy propaganda. The Zero's success had bred dangerous confidence in Japanese aviation circles. Naval commanders believed their technological superiority was permanent. Admiral Yamamoto himself had declared that American fighters were crude and heavy, built by engineers who prioritized production over precision. This arrogance would prove catastrophic. While Japan celebrated Zero victories, American factories were revolutionizing aircraft design at a pace that defied comprehension. Now Horikoshi stared at blueprints that revealed the true scope of American engineering capability. The P-38 Lightning featured 2 Allison V1710 engines, each producing 1,175 horsepower. Combined, these power plants generated nearly 3,000 horsepower, more than double the Zero's single Nakajima Sakai engine, but raw power was just the beginning. The Lightning's twin-boom design allowed for a central nacelle housing the pilot and armament, creating aerodynamic efficiency that seemed impossible. The aircraft's top speed reached 414 mph at 25,000 feet. Nearly 100 mph faster than the Zero's maximum velocity. More devastating was its operational ceiling of 44,000 feet, giving Lightning pilots the ability to choose when and where to engage. Japanese Zeros operated effectively up to 33,000 feet. Above that altitude, their performance degraded rapidly, while Lightnings maintained full combat effectiveness. American pilots could literally fight from another dimension of altitude. Range statistics made Horikoshi's stomach turn. The Zero's exceptional range of 1,229 miles had been its greatest tactical advantage. Japanese planners had designed Pacific strategy around this capability, but the P-38 Lightning, with external drop tanks, could fly a fund 300-mile combat radius, allowing it to escort bomber formations deeper into Japanese territory than military planners had thought possible. American bombers were no longer fighting alone. Horikoshi studied the Lightning's armament configuration with growing dread. 4 50-caliber machine guns and 1 20mm cannon, all mounted in the nose cone. This arrangement eliminated the convergence problems that plagued wing-mounted guns. Every round fired traveled the same trajectory. Japanese fighters relied on wing-mounted weapons that required precise range estimation for effective convergence. Lightning pilots could fire accurately at any distance within their gun's effective range, but then Horikoshi discovered something that made his blood run cold. The P-38's contra-rotating propellers eliminated torque effects that caused single-engine fighters to pull left or right during high-power maneuvers. This seemingly minor detail provided Lightning pilots with precision control that Japanese engineers hadn't even recognized as a problem. American designers were solving engineering challenges that Japan's best minds hadn't identified. The twin-engine configuration offered another devastating advantage: redundancy. Zero pilots knew that a single engine failure meant certain death over water. Lightning pilots could lose one engine and still return to base. This psychological advantage was immeasurable. American pilots could engage aggressively, knowing they had backup systems. Japanese pilots, flying single-engine aircraft, fought with constant awareness that one lucky shot could end everything. Horikoshi examined the Lightning's turbocharged engines with disbelief. These systems maintained full power output at altitudes where Zero engines gasped for oxygen. American pilots could dive from 30,000 feet at full power, while Zero pilots watched their engines lose effectiveness. Combat reports from Guadalcanal described Lightning attacks that seemed to come from nowhere, diving from altitudes where Japanese lookouts couldn't see them coming. Production numbers told an even more terrifying story. Lockheed was building P-38 Lightnings at a rate of 500 aircraft per month. By early 1943, Japan's entire aircraft industry was producing fewer than 800 fighters monthly across all manufacturers and models. America was building more of this one advanced fighter type than Japan could produce of all its aircraft combined. The industrial mathematics were impossible to ignore. Quality control data revealed another crushing reality. American factories maintained tolerances that Japanese craftsmen achieved only through hand-fitting individual components. The Lockheed P-38 Lightning aircraft rolled off assembly lines with a precision that required weeks of manual adjustment on the iconic Zero fighter production lines. American industrial methods were producing superior quality at impossible speeds. Henry Ford's assembly line techniques had been applied to advanced fighter aircraft production. Aerospace engineer Horikoshi read combat reports that described Lightning tactics with growing despair. American pilots were using altitude and speed advantages to dictate every engagement. They dove from above, made high-speed passes, and climbed away before Zero pilots could even respond. The classic dogfighting techniques that made Zero pilots legendary were becoming irrelevant. American fighters didn't need to turn and burn when they could hit and run at will. Intelligence estimates suggested that America was training Lightning pilots At 6 times the rate Japan could produce 0 pilots. American flight schools were graduating combat-ready aviators every 2 weeks. Japanese training programs required 6 months to produce pilots with equivalent skill levels. The mathematical implications were staggering. Even if Zero aircraft could match Lightning performance, Japan lacked the human resources to sustain extended air combat. Fuel consumption data revealed strategic implications that terrified military planners. The P-38's fuel efficiency, despite its twin engines, allowed longer patrol times than single-engine Japanese fighters. American pilots could remain on station for extended periods, while Japanese fighters faced constant fuel management concerns. Lightning formations could patrol territories that Zeros could barely reach. The Lightning's radio equipment specifications showed technological advances that bordered on science fiction. American pilots communicated with ground control at ranges exceeding 200 miles. Japanese aircraft radios operated effectively at distances under 50 miles. Coordination between Lightning squadrons resembled orchestra performances. While Japanese formations fought as isolated units, American fighters were networked. Before that term even existed, Horikoshi examined the Lightning's oxygen system. With grudging admiration, pilots could operate at maximum effectiveness above 35,000 feet for hours. Zero pilots began experiencing hypoxia symptoms above 30,000 feet, despite their oxygen equipment. This physiological advantage meant Lightning pilots literally thought more clearly during high-altitude combat. American technology was enhancing human performance, while Japanese pilots fought against their equipment's limitations. Navigation equipment aboard Lightning aircraft represented another technological chasm. American pilots carried radio compasses, radio beacons, and radar interrogation equipment that provided position accuracy within miles. Japanese pilots navigated using magnetic compasses and dead reckoning techniques that accumulated errors over long distances. Lightning pilots knew exactly where they were, while Zero pilots operated on educated guesses. But then Horikoshi discovered something that shattered his remaining confidence completely. Intelligence reports indicated that the P-38 Lightning was not America's newest fighter design. It was already being replaced by even more advanced aircraft. In American production lines, the Republic P-47 Thunderbolt and the North American P-51 Mustang represented evolutionary steps beyond the Lightning's capabilities. America was developing next-generation fighters, while Japan struggled to understand current-generation technology. Industrial capacity reports painted a picture of hopeless disadvantage. American aircraft factories operated 3 shifts daily, 7 days weekly. Production lines never stopped. Japanese facilities operated single shifts with frequent maintenance delays. American workers lived in heated factories with modern conveniences, while Japanese workers faced material shortages and power restrictions. The industrial base supporting Lightning production was larger than Japan's entire manufacturing economy. Material science data revealed technological gaps that seemed insurmountable. American aluminum alloys provided strength-to-weight ratios that Japanese metallurgy couldn't match. Lightning airframes used aluminum formulations that Japanese engineers couldn't reproduce with available resources. American fighters were built from superior materials, using advanced manufacturing techniques that required industrial infrastructure. Japan couldn't develop quickly enough. Horikoshi studied Lightning maintenance requirements with growing admiration for American engineering philosophy. Complex systems were designed for field maintenance by technicians with basic training. Japanese aircraft required specialist mechanics for routine maintenance procedures. American fighters could be serviced at forward airfields, while Japanese aircraft needed depot-level facilities for comparable maintenance. Operational availability favored American aircraft by enormous margins. Weather performance specifications showed another crushing American advantage. Lightning aircraft operated effectively in weather conditions that grounded Japanese fighters. Advanced de-icing systems, weather radar, and instrument flight capabilities allowed American pilots to fight in South Pacific storms that provided natural protection for Japanese aircraft. Weather was no longer a tactical ally for Japanese forces. Training aircraft data revealed long-term strategic implications that made victory impossible. America was training Lightning pilots in aircraft that closely matched combat performance characteristics. Japanese pilot training relied on obsolete aircraft that poorly prepared aviators for iconic Zero fighter performance. American pilots transitioned smoothly from training to combat, while Japanese pilots faced steep learning curves that cost lives and aircraft. Logistical support requirements painted the final picture of American superiority. Lightning squadrons operated with supply chains that delivered parts, fuel, and ammunition reliably across South Pacific distances. Japanese aviation units faced constant shortages of everything from spark plugs to aviation fuel. American fighters flew regular missions, while Japanese aircraft sat grounded, waiting for basic maintenance supplies. At 3:47 p.m. that same day, Horikoshi walked into Admiral Yamamoto's office carrying his resignation letter. The admiral who had planned Pearl Harbor found his chief aerospace engineer pale and shaking. Horikoshi placed the Lightning blueprints on Yamamoto's desk and spoke words that would haunt Japanese military leadership. "Sir, we are not fighting an enemy air force. We are fighting an enemy air armada, equipped with flying machines from the future. Our aircraft are beautiful works of art, but theirs are industrial weapons, designed to win wars." Admiral Yamamoto studied the acquired blueprints in silence for 20 minutes. When he finally looked up, his eyes showed the same despair that had driven Horikoshi to resignation. The admiral, who had warned Japanese leadership about awakening a sleeping giant, was seeing that giant's true industrial capacity for the first time. America hadn't just awakened, it had transformed into a technological colossus that made Japanese military planning obsolete. 3 weeks later, Horikoshi's assistant, let's call him David Miller, found his private notes hidden in his office safe. The final entry, dated March 15th, 1943, read, "Today, I saw our defeat written in aluminum and steel. The Americans have built lightning that strikes from heaven itself. Our iconic Zero fighter is a samurai sword fighting 50 caliber machine guns. Beautiful, deadly, but obsolete. May God forgive us for what we have brought upon our people." The resignation of Jiro Horikoshi sent shockwaves through Japanese aerospace engineer circles that reverberated for months. Naval commanders attempted to suppress news of his departure, but word spread among engineers and pilots. If the man who designed the iconic Zero fighter had lost faith in Japanese aviation technology, what hope remained for ultimate victory? Morale among design teams plummeted as other engineers requested transfers to non-aviation assignments. Production statistics from the months following Horikoshi's resignation revealed the psychological impact of the Lightning revelations. Zero production rates declined by 23%, as quality control engineers obsessed over details that couldn't bridge the technological gap. Japanese factories began over-engineering components in desperate attempts to match American performance standards. These efforts actually reduced aircraft quality, while consuming resources desperately needed elsewhere. Combat reports from South Pacific theaters confirmed Horikoshi's worst fears. Lightning squadrons were appearing in areas previously considered safe Japanese airspace. The aircraft's range and speed allowed deep penetration missions that disrupted Japanese logistics and communications. Zero pilots reported encounters where lightning formations attacked from altitudes and directions that seemed impossible. American pilots were fighting three-dimensional chess, while Japanese aviators played checkers. Intelligence reports from captured American airfields revealed production capabilities that defied comprehension. Photographs showed Lightning aircraft lined up in formations that stretched beyond camera range. Maintenance facilities operated around the clock with efficiency that Japanese engineers couldn't achieve during daylight hours. American aviation logistics resembled modern industrial operations. While Japanese facilities operated like traditional workshops, pilot training reports painted an equally devastating picture. Captured American aviators described flight training programs that produced Lightning pilots in half the time required for zero certification. American training methods used advanced simulators, specialized aircraft, and standardized procedures that maximized learning efficiency. Japanese pilot training relied on traditional apprenticeship methods that couldn't scale to wartime requirements. The psychological warfare value of Lightning aircraft became apparent as Japanese pilots began reporting mysterious aircraft sightings. The Lightning's distinctive twin-boom silhouette created identification problems that contributed to pilot stress and confusion. Japanese aircrews began seeing Lightning aircraft where none existed, degrading combat effectiveness through phantom aircraft syndrome. Fear of Lightning encounters was becoming more tactically significant than actual Lightning presence. Strategic bombing missions escorted by Lightning fighters demonstrated the aircraft's most devastating capability. American bombers were reaching targets deep in Japanese territory with Lightning escorts that outperformed Japanese interceptors. The Zero's inability to effectively engage Lightning escorts meant bomber formations operated with near impunity. Japanese air defense planning became an exercise in accepting inevitable losses. By June 1943, 3 months after Horikoshi's resignation, Japanese aviation strategy had shifted from seeking air superiority to minimizing losses. Zero pilots received new orders emphasizing survival over victory. Engage only when absolutely necessary. Avoid Lightning formations when possible. Preserve aircraft and pilots for defensive operations. These orders represented the death of Japanese offensive aviation capability. Industrial espionage efforts revealed American production plans that made resistance seem futile. Intelligence reports indicated Lightning production rates would triple by the end of 1943. New fighter designs entering American service would make Lightning aircraft seem obsolete by comparison. Japan was fighting yesterday's American Air Force, while tomorrow's American Air Force was already in production. Fuel supply calculations demonstrated another dimension of American advantage. Lightning squadrons consumed aviation fuel at rates that exceeded total Japanese fuel production capacity. American pilots could afford to train extensively, conduct long-range patrols, and engage in combat operations that Japanese pilots considered wasteful. Fuel abundance was translating into tactical flexibility that Japanese forces couldn't match. The capture of Lightning aircraft components through combat salvage operations provided Japanese engineers with detailed examinations of American manufacturing techniques. Materials analysis revealed metallurgical advances that Japanese industry couldn't reproduce without fundamental changes to production methods. American fighters were built using industrial technologies that Japan would need years to develop, even with captured examples for reverse engineering. Combat reports from experienced Zero pilots described psychological effects that military leaders found alarming. Veterans who had dominated South Pacific skies during 1941 and early 1942 were requesting ground assignments rather than face lightning squadrons. The aircraft that had made Japanese pilots feel invincible was creating feelings of helplessness when confronted with American technological superiority. Medical reports from Japanese air bases documented stress-related illnesses that correlated with lightning encounter rates. Pilots operating in areas with frequent lightning activity showed elevated rates of anxiety, insomnia, and psychosomatic disorders. Flight surgeons reported that fear of lightning combat was creating medical casualties before pilots entered actual combat situations. American technology was defeating Japanese aviators through intimidation, as much as direct action. Communication intercepts revealed American pilot confidence levels that bordered on arrogance. Lightning pilots discussed combat engagements in casual terms that suggested Japanese aircraft posed minimal threats. Radio conversations included jokes about iconic Zero fighter performance and dismissive comments about Japanese pilot capabilities. American aviators were treating air combat as routine business rather than life-or-death struggles. Maintenance reports from Japanese air bases showed declining aircraft availability as ground crews struggled to keep aging Zeros operational. Parts shortages, material degradation, and increased combat damage were reducing aircraft readiness rates below sustainable levels. Lightning squadrons operated with aircraft availability rates above 85%, while Japanese units struggled to maintain 60% readiness with their aging fleet. Navigation and communication equipment captured from Lightning aircraft revealed technological capabilities that seemed almost magical to Japanese aerospace engineers. Radio equipment operated reliably at ranges that exceeded Japanese equipment capabilities by factors of 3 or 4. Navigation instruments provided position accuracy that Japanese pilots achieved only through perfect weather and landmark navigation. American technology was providing pilots with godlike awareness of their tactical environment. Weather reporting systems supporting Lightning operations demonstrated another American advantage. The Japanese planners hadn't anticipated. Meteorological services provided American pilots with weather information that allowed precise mission planning and execution. Japanese pilots operated with weather information that was often hours old and geographically limited. American pilots fought with tomorrow's weather, while Japanese pilots reacted to yesterday's conditions. Research and development reports captured during intelligence operations revealed American aviation programs that made current Lightning technology seem primitive. Next-generation fighter designs incorporated jet propulsion, radar systems, and weapons technology that represented evolutionary leaps beyond current capabilities. America was developing Lightning replacements, while Japan struggled to understand Lightning technology. Horikoshi's resignation had removed Japan's most gifted aerospace engineer at precisely the moment when his expertise was most desperately needed. Replacement engineers lacked his intuitive understanding of state-of-the-art aerodynamics principles and his ability to optimize designs for maximum performance. Japanese aviation engineering entered a decline period, exactly when American aviation engineering was reaching unprecedented heights of capability and innovation. Factory production reports from the months following the Lightning revelations showed declining quality standards as Japanese manufacturers attempted to incorporate advanced features without understanding underlying engineering principles. Aircraft rolled off production lines with modifications that actually reduced performance while increasing weight and complexity. Desperate attempts to match American technology were making Japanese aircraft worse rather than better. Training programs for Japanese aerospace engineers revealed knowledge gaps that couldn't be bridged quickly enough to matter strategically. American engineering education emphasized practical application and industrial efficiency, while Japanese programs focused on theoretical knowledge and individual craftsmanship. These educational differences were producing engineers who approached aircraft design from fundamentally different philosophical perspectives. Intelligence estimates of American aviation production capacity through 1944 painted a picture of overwhelming industrial superiority that made continued resistance appear suicidal. Projected Lightning production rates would place thousands of advanced fighters in the South Pacific theaters, while Japanese production struggled to replace current losses. Mathematical analysis of relative production capabilities suggested that Japan would face 10 American fighters for every Japanese aircraft by mid-1944. The Lightning's impact on Japanese aviation strategy extended beyond tactical considerations to fundamental questions about Japan's ability to prosecute modern warfare against industrial powers. Aircraft represented concentrated industrial capability, and Lightning squadrons demonstrated American industrial power that dwarfed Japanese manufacturing capacity. Warfare had become industrial competition, and Japan was competing with handicrafts against mass production. By the end of 1943, 8 months after Horikoshi's resignation, Japanese aviation strategy had evolved into pure defensive operations, designed to delay inevitable defeat rather than achieve victory. Lightning aircraft had become symbols of American technological supremacy that demoralized Japanese pilots and ground crews. The psychological impact of facing technologically superior aircraft was destroying Japanese aviation effectiveness. More completely than direct combat losses, intelligence reports from Japanese-occupied territories revealed that civilian populations were losing confidence in Japanese military capabilities after observing Lightning aircraft operating over previously secure areas. The sight of American fighters conducting operations deep in Japanese-controlled airspace was undermining occupation authority and encouraging resistance activities. Technology was becoming political warfare. Supply chain analysis demonstrated that Lightning squadrons operated with logistical support that exceeded total Japanese aviation supply capacity. American fighters received maintenance support, spare parts, fuel, and ammunition at rates that Japanese units couldn't achieve even during peacetime operations. Wartime logistics were revealing industrial capabilities that made Japanese resistance calculations meaningless. Communication intelligence revealed American operational planning that treated Japanese air opposition as minor factors in mission planning rather than primary considerations. Lightning squadrons planned operations assuming air superiority rather than fighting for it. This operational confidence reflected technological capabilities that had fundamentally altered the strategic balance in South Pacific air warfare. The resignation letter that Horikoshi submitted on March 15, 1943, concluded with words that would prove prophetic. "We built aircraft to honor tradition and demonstrate craftsmanship. They built aircraft to win wars. Our defeat was inevitable from the moment we chose beauty over battlefield effectiveness. Future generations will judge us harshly for believing that artistic achievement could triumph over industrial capability." Today, nearly 80 years later, the P-38 Lightning remains one of history's most innovative fighter aircraft designs. Its twin-boom configuration influenced jet aircraft development for decades. The turbocharged engines, they pioneered high-altitude fighter operations, and those operations became standard throughout the Cold War era. Advanced navigation and communication systems. They established technological foundations for modern air combat capabilities. Modern aviation historians recognize the Lightning's critical role in establishing American air superiority, and that superiority enabled strategic bombing campaigns against the Japanese home islands. Without Lightning escorts, American bombers simply couldn't have operated effectively in Pacific theaters. The aircraft's long range and high-altitude performance made strategic air warfare possible across Pacific distances that exceeded any previous military operations. Museum collections worldwide preserve Lightning aircraft as monuments to American industrial capability during World War II. Restored aircraft demonstrate the engineering excellence that demoralized enemy aviators, and it convinced brilliant designers like Horikoshi that resistance was futile. These museum pieces represent frozen moments when American technology shocked the world and changed warfare forever. Veterans who flew Lightning aircraft describe the psychological impact of superior technology on combat effectiveness. Pilots knew their aircraft could outperform any enemy fighter, creating confidence that translated into aggressive tactics and superior combat results. Technology was providing competitive advantages that made individual pilot skill less important than aircraft capability. The Lightning's legacy extends beyond military aviation to commercial aerospace development. Engineering principles pioneered in Lightning design influenced passenger aircraft development throughout the 1950s and 1960s. Twin-engine configurations, pressurized cabins, and advanced navigation systems trace technological lineage directly to Lightning innovations. Military aircraft technology was transforming civilian aviation. Engineering schools worldwide study Lightning design as an example of innovative thinking that solved complex technical problems through unconventional approaches. The twin-boom configuration represented fresh thinking that challenged traditional aircraft design assumptions. Students learn that technological breakthroughs often result from questioning basic assumptions rather than incremental improvements to existing designs. Historical analysis reveals that the Lightning's impact on Japanese strategy extended far beyond aviation to fundamental assessments of American industrial capability. Japanese military planners began questioning assumptions about American resolve and capability that had justified war planning. Superior aircraft became symbols of superior national power that undermined confidence in ultimate victory. Research into Japanese wartime decision-making suggests that Horikoshi's resignation influenced high-level strategy discussions about negotiated peace settlements. If Japan's best aerospace engineer believed American technology was insurmountable, perhaps military victory was impossible, regardless of tactical successes. Technical reality was overriding political ideology in strategic planning circles. The story of Lightning aircraft demonstrates how technological superiority can achieve strategic objectives that exceed the sum of tactical advantages. Superior aircraft created cascading effects that influenced morale, logistics, training, production, and ultimately, strategic decision-making. Technology was becoming a force multiplier that transformed military capability beyond simple performance comparisons. Documentary evidence from Japanese archives reveals that Lightning aircraft influenced home front morale as civilian populations observed American fighters operating over Japanese territory with apparent impunity. Superior technology was becoming psychological warfare. That undermined popular support for continued resistance. Aircraft performance was translating into political impact. Military historians recognize the Lightning's role in establishing technological warfare principles that dominated military thinking throughout the Cold War era. Superior technology could compensate for numerical disadvantages and provide strategic advantages that transcended battlefield tactics. The Lightning established technology as the primary determinant of military capability in modern warfare. The preservation of Lightning aircraft in museums worldwide ensures that future generations can study the engineering innovations that helped win World War II. These aircraft represent American industrial capability at its wartime peak and demonstrate how technological innovation can achieve strategic objectives that change world history. They stand as monuments to the engineers, workers and pilots who built and flew Lightning that struck from American skies. Every restored Lightning reminds us that freedom flies on wings built by free people. The aircraft that forced brilliant engineers to resign in despair became symbols of democratic industrial power that preserved liberty for future generations. Jiro Horikoshi designed beautiful aircraft, but American engineers built aircraft that won the war and secured the peace. That followed. The mathematical reality of what happened that day, in March 1943, still staggers military historians. America was producing advanced fighter aircraft at rates that exceeded total Japanese aircraft production across all types and manufacturers. Detroit assembly lines were building P-38 Lightnings faster than Japan could build training aircraft. Rosie the Riveter and millions like her were constructing technological marvels that made enemy engineers question everything they believed about aviation. Your grandfather might have worked those Michigan assembly lines, installing electrical systems or riveting aluminum panels on Lightning fuselages. Your grandmother might have operated precision machinery that shaped wing components for aircraft that would fly. Over Tokyo itself, Main Street America was building the arsenal of democracy, one Lightning at a time. And every aircraft carried the hopes and determination of free people who refused to accept defeat. When Horikoshi submitted his resignation, he wasn't just quitting his job. He was acknowledging that democratic industrial might had achieved something that authoritarian systems couldn't match. Free workers, building free aircraft for free nations, had created technology that overwhelmed the finest engineering minds of totalitarian regimes. Liberty itself was flying at 414 miles per hour with twin Allison engines roaring defiance across Pacific skies. The Lightning squadrons that appeared over Japanese territory carried more than bombs and bullets. They carried the message that American industrial democracy could outproduce, out-innovate, and outfight any enemy that threatened freedom. Every Lightning mission was a demonstration that free societies possessed inherent advantages that dictatorships couldn't overcome through force alone. Those young American pilots flying Lightning aircraft over hostile territory weren't just completing military missions. They were proving that technological excellence emerged from societies that rewarded innovation, encouraged individual initiative, and channeled competitive energy toward common purposes. Every Lightning formation was democracy in action, demonstrating that free people could build better aircraft than enslaved populations. The families waiting at kitchen tables across America, while their sons flew Lightning missions over the South Pacific, were contributing to victory through their support. their work, and their unwavering belief that American technology and American courage would prevail. Sunday dinner tables with empty chairs represented sacrifice that powered the industrial miracle that built Lightning aircraft by the thousands. Historical archives preserve letters from Lightning pilots describing their aircraft with affection and respect that bordered on love. These young Americans understood that their Lightnings represented the best efforts of free people, building the finest aircraft possible. They flew with confidence that came from knowing that American engineering, American manufacturing, and American determination had provided them with technological superiority. The story of Jiro Horikoshi's resignation reminds us that technological excellence requires more than brilliant individuals. It requires societies that support innovation, reward creativity, and channel competitive energy toward constructive purposes. The Lightning aircraft that demoralized enemy aerospace engineers were products of American social systems that encouraged technological advancement. Modern Americans inherit the legacy of those wartime achievements every time commercial aircraft take off from airports worldwide. Jet engines, pressurized cabins, advanced navigation systems, and reliable communications equipment trace technological lineage to innovations pioneered in aircraft like the P-38 Lightning. Your freedom to travel the world safely owes debts to engineers who built military aircraft that preserved the peace. Today's military pilots fly aircraft that represent evolutionary developments, from Lightning innovations, advanced fighters, strategic bombers, and support aircraft carry forward engineering principles established when American democracy faced its greatest technological challenge. The tradition of American aviation excellence that intimidated enemy aerospace engineers continues in modern aircraft that defend freedom worldwide. These aren't just statistics from dusty archives or museum pieces gathering dust behind velvet ropes. They're monuments to the generation that saved the world through technological excellence, industrial determination, and unwavering commitment to freedom. Every preserved Lightning aircraft stands as testimony that free people, properly organized and adequately supported, can achieve technological miracles that astound enemies and inspire allies. The engineering principles that made Lightning aircraft superior to Japanese designs continue influencing aircraft development today. Twin-engine reliability, high-altitude performance, long-range capability, and advanced electronics represent technological themes that began with aircraft like the P-38. Innovation never stops, but it builds upon foundations laid by previous generations who faced seemingly impossible challenges. If preserving these stories matters to you, if honoring the memory of those who served and those who supported them resonates with your values, the YouTube Super Thanks feature helps maintain channels dedicated to historical accuracy and respectful remembrance. Veterans deserve accurate portrayals of their service, and their families deserve preservation of their legacy. What moment in this story made you feel most proud of American technological achievement? Was it learning about production rates that exceeded enemy capacity, the engineering innovations that seem advanced even today, or the human courage that made technological superiority meaningful? Leave your thoughts below and share any family connections to wartime aviation. These personal stories help preserve history in ways that statistics alone cannot accomplish.